Okay. Hello. Let's just get right to it. So last time we added tags, which is pretty cool. Can add a custom tag there. And see, we can tag things, the metaprogram can look at them. Great. Today we are going to finally make snippets more of a fully featured macro replacement. So right now I still use macros for a few things, like or maybe I don't. Maybe I don't use macros anymore in the DB files. Let's double check real quick. Jeez, sorry. Oh, I had that right the first time. Primary chunk. So we do use it here, but that's fine. That's in the generated C code. We're not parsing that. So because we eventually just spit out C, it's okay that we spit out pound defines. So the metaprogram can spit out pound defines. That's fine with me. It's as long as we're not using them in the code. But so we're already not using macros, so that's good. But one thing that we're missing from snippets, two things really that we're missing from snippets that we really want the functionality of, is we don't have a way to take whatever you passed and create a, like, append a variable name basically. So with a macro you can basically, in fact I have an example of that here. So like this assert uses macros. One thing you can do with a macro that is really nice is actually, let's go to the utility code here. So a really nice thing about a macro is, wait, do I even do this here? I'm a little all over the place tonight. It's okay. Okay, we don't actually use it here. You can basically take whatever you passed in to this macro. So like value here, and you can basically say have a new variable. Right? And you can do all sorts of things like append the thing you passed in, like as a variable name. You can turn it into a string. So like if you do look at our assertion macro here, you have to do a little bit of wonky stuff, like you need a initial macro to just stringify what you passed, and then you need a second macro to expand the thing that you passed into the first stringify, and then you can call that, so that way it'll expand, like it'll turn the line number into a string and stuff. A bunch of weird stuff there that I can kind of brute force and skip over all that nonsense with snippets. But we don't have an ability to do any of this stuff right now in snippets. We can't stringify things. We definitely can't stringify something that is expanded. So, although the idea of expanding isn't really a thing for snippets, so we really just want a way to stringify and concatenate strings, probably. And this isn't strictly a snippet thing, but I also want to replace these compiler directives for line number, file name, function. There's also a counter. I want to replace those as well and have basically pre-proc directives for those things. So like file, probably file name, line number, function, and I guess just counter. Is that what I said that we're doing here? I think. Yeah, so I want to do that as well. And with these four things and the ability to stringify things in a macro, and really all that means is take the thing that you passed and get a string version of it. So like here, line is a U32, or is like an int. I want this to be a C string that's L, number, sign, and then as a string, this variable, which is a number. I want to be able to do that in a snippet. So let's start similar to last night. Let's start by adding those keywords to forcoder. So once again, here's where I added like the tag last night, for example, or these other pre-procs. We're just gonna add 1, 2, 3, 4 more of them. God, I got a frog in my throat tonight. So we're gonna say file name, line number, function, and counter. Oop. Okay, file name, line number, function, and counter. Okay, so let's close forcoder. Let's recompile that in a place where you can actually see it. And do the whole thing. So this just recompiles the forcoder custom layer to, oh, I did not mean to close that. That's what I get for talking while doing it. Okay. Set face size. Let's make this big again. Okay, so now if I open this back up, there you go. So now these are highlighted just like the other ones. Easy first step. So now let's go to the parser and let's add pre-procs for all these. What was the order? File name, line number, function, counter. Okay. And after tag here, okay, so we've added those. Let's go to the lexer and make sure that that is grabbing them properly. So pre-proc, so let's see, any, so these all do the same thing, except we special case the snippet because why? We add, that's the same, that's the same, that's the same, but then okay, that's fine. We handle snippets separately. Snippet is a special case to handle the parens and stuff. Although, I feel like we don't have to do that. Well, yeah, I guess we do, because preprocessor parameters are handled differently. So, for custom directives, we just use a table lookup. So let's simplify this. Let's go up here and let's add a new short string array for custom directives. We have any of, type tag, and then the four we just said, file name, line number, function, counter. So we can say I'm gonna loop over this, and if so directive equals this custom directive. So if this one equals one of our custom ones, we can add, right, I need to pair that with a token. Oh, there's also external. I forgot that. So external uses a generic preproc, whereas all these other ones don't, and I'm wondering why they don't. External. So values external depend. So why is that? Snippet is a special case, that's fine. Depend is not. It's a preproc also. Where is depend in here? It's just handled like normal. Oh, it's handled like include, that's why. Which is fine, it has a body. You know what, we'll call this custom simple directives, because they don't take any kind of parameters or have a body. I mean, technically any of does, but that's handled by the parser. So, so this can be custom simple directives. And I think what we need to do, we need to pair these with a token. So, directive, simple directive token pair. Wait. And this will just be a short string, which is the directive, and a token type. Token. So actually these are simple directive pairs. Let's do this. Boom, boom. Sorry about that. Okay. So this will be a token any of, token type, token tag. External, I think, is just a preproc. Token preproc. These can all be preprocs. I think all of these could have been preprocs, and I just was not. It's a little bit easier to deal with them as their own entity. So it's a little wasteful. Those don't really have to be that way, but it's fine. So now the token here, if the directive is this dot directive, then the token here will be the token. So any is good, any of is good, type is good, tag is good, external is good, and now we have our other ones too. Let's make sure we didn't break something. This is the wrong thing. Great, we still compile. That's good news. Great. So, and now we have custom directives. So this should be fine for now. Nothing should break there because we at least understand what it is. Yep. Cool. Now in the parser, let's add another one of these for each thing. And let's just start with the file name. So if the value's file name, for now, let's just say that we see it. I see you. Should add that back in. There we go. Why do we see it so many times? Because now... Oh, because now... Okay, now we're not skipping it. That's fine. Let's skip it. There we go. Okay, so we see it. That's fine. Oh, actually, while I'm here, parse potential tags. I actually saw when I was randomly when I was checking the audio on the last stream to make sure it was correct. I actually noticed that I have a typo in here. A really dumb typo that was staring me in the face. And I didn't notice it the entire time. First indentifier. And actually, we don't even use this. We just want to skip it. Count the first one. So we actually don't even need that. I'll just do this. Yeah, just a little bit of cleanup. Doesn't matter, but... Okay. Okay, so... when we see the file name directive, we want to replace that node, or no, we want to add a string literal that is the name of the file, is what we want to do. So add a string literal node containing the name of this file, of the source file. So we're gonna say file name node is a new preproc. Oh wait, Do we do that here? That's probably fine. Yeah. I was gonna say, do we need to make a separate node type for this? I think I can just replace it with a literal string. So, okay. Assert that we made one. No tags. Skip it. Do parse. But the file name node, info literal string. Is that what we said this was? Literal. Oh, set the type. The type will be a token literal string. And the string itself will be the name of the file, which should be current lexer, parser, current lexer, file path. File path? Or just the name? Is that the full path to the file? Let's do this. File name. Let's do this. Parser, cur, lexer, file path. I think this is going to be the full path, which means we need to do a little bit of work on it. Let's write out the file name. External node, that's not what this is called. Dot string. Value dot string, because this is a union. Dynamic string and short string. Oh. That's a dynamic string? Okay. Well, allocate D string. Sure. Okay, yeah, see, this is the entire path. Obviously, right now it's just dot slash, but it's the entire path. So, I really want the substring from the right-hand side all the way to the slash. We'll say file path. Short string file name is equal to substring. It's a short string from a short string. File path. The start index will be char index from right, and the end will be file path dot length -1. So we want the whole thing starting from file path slash +1. Oh, but what if there is no slash in it? What happens then? Char index from right. So normally, char index from left. Oh, it returns a -1. Never mind. I thought it returned like the beginning of the string, which it doesn't. So start index equals slash index is this. Slash index is this is an S32. If slash index is greater than or equal to 0, we want slash index +1. Wait, no, that's actually fine. If that returns a -1, we can just do +1, right? Because then it'll just start at the beginning. And in fact, character index from left should probably be similar. That should return the length of the string. we return the length of source here, its functionality will be symmetrical. Is that how you spell symmetrical? No. That's how you spell it. 2 M's. Will be symmetrical to from right, in that you can safely just grab the result and subtract 1 from it, and it will behave as you expect. Add 1 in the from right case. Okay, so /index all the way to the end of it. There we go. And just to verify, so if I say file path is equal to test more directories, file.cpp, that should work. File.cpp, and I'm trying to think actually, does this give you the full path? Is it just file? No, it does not. Oh wait, maybe it does. I should print out the file path here. I don't actually know. That does give you the full path. Okay, maybe that's fine. It won't be the full path, it'll just be the it's like the truncated version of it basically. So like in our case, it is relative to the working directory, so this isn't quite the full path, but that's fine, it doesn't need to be. Because I'm trying to think, if there's a case where you have 2 files with the same name in different directories, that won't really happen, but maybe I do just want the normal file name. No, it's fine. Let's just match what C does. It's okay. Okay, so that's file name. So let's verify that if we're adding this, so now out here should just be a floating string, which, yes, so now it's you see there's a failure. It's like, hey, there's a literal string floating out here in global scope. I don't know what that is. So that's good. That means that actually worked. And if I go to main, and let's just print, like, the file name. Let's just see if that works. Function call. Expected expression got preproc file name. That shouldn't be the case though. There should not be a preproc in there. This should be getting replaced. That should be getting replaced with a string literal. Let's look at the tree. No, it's at parsing. Hold on. It should be replacing this with a string literal node, which is what we're doing here. So it's parsing. Boom, it sees this. It's a... Oh, it's a function call. It's seeing... Right. This is if it's floating out in the middle of nowhere, which it's not. This needs to be in parse expression is where this needs to be. Right. So, parse expression leaf. We need a new thing here because now we have a preproc that can exist in a expression. So token keyword, fundamental type. Let's just put it here. So else if next type is a token preproc. Is that what we said this was? Yeah, token preproc. So if it's a preproc, we have different cases. If next, do we have the text already? Do we even use the text anywhere in here? No. Short dynamic string. Directive is get token text next. Okay, so we're gonna grab this, what we did here, do this whole thing. Yeah, we're not gonna do this at all. So forget this whole thing. And in here, if the directive is file name, what does this function return? It returns a node, right? Yes. We're creating a node here. So same thing. Return a string literal node containing the name of the source file. So we will still create a node. We don't need any of this stuff though. It's just a string literal node. Wait. That's not true. We need the parser. We just don't need the root. Create a literal string. Assert we got one. Same thing. Put the file path on it. Don't need this. Skip past it. Yes. Skip past it. Don't need... Oh, that was actually erroneous anyway. We didn't need the do parse. Okay. Now this should work. Make sure this file is still print file name. Got token preproc. We still have one. Wait, why? Expected expression. Oh, hold on. That's why. Because starts expression needs to be aware of that. So if it's an expression keyword, we'll say preproc expression. We will say token type equals token preproc and text is file name, or we'll just do this. File name line number function counter. Okay, great. Now we should be okay, he says. 303, what did I do? Forgot a semicolon. And you know what? It helps to actually use this thing too. Parse call. Okay, so now param node on 1389. Param node is parse the parameters. If next type is a comma, otherwise parse expression. Oh, we didn't get a node back. That's true. We didn't get a node back because result equals file name node. We didn't actually do anything with it, so it's kind of important that you do that. Let it know that you actually got one. No matching function call for print this and a short string format U32. Oh, this is a different error, so sorry, I keep bumping the mic. So this is a problem. It's generating, if you go look here, what I think is happening is it's generating, oh god, stop. Print, okay. It's generating a const char star version of print for like C strings. It is not generating a separate short string version, even though technically those should be two different things. Although, let's look at print real quick. Oh, no, it's not. Okay. Right. Those should be two separate things, which means param. Do I define a print in here for short strings? This is the wrong. Oh, wait, no. Int to string. I don't actually need this anymore. Well, yeah, I guess I do, because this does some extra stuff. But where is... Yeah, I don't have one for... I feel like I want to have a print function for short strings, specifically. And dynamic strings. You know what I'm saying? Is there a reason I don't have this? I feel like there's a reason I don't have this. Oh, no, I do. Okay, we have this toString. We just don't have a print. But print should just be calling format string. I think it's a type matching thing that's happening here. Param the fuzzy matching. Fuzzy match. Where's fuzzy match? Matches string type. Yeah, so this is where that's happening. Let's, if I exclude this, what happens? I guess in this specific case, is it okay to have a special print? No, it's not, because... because it's an any. So I think if I go look at the generator for this, no, it's in, is it metaprogram? These are the two strings. Where's the where's the print getting generated? Oh, because it's a function template. Okay, yes. Let's remove this. So, param types match. Does this do a fuzzy match? Yes, it does. This does a fuzzy match here. Right here. They do fuzzy match, so in this case, well, wait, I wonder if, does this not implicitly convert to a C string? Is that not what that does? See, I thought by having this here, it's a constructor that takes a const char star, that it should implicitly convert to this. But it doesn't. Because I believe this same thing will happen if, instead of this, and I just do this, I think this will still happen. It doesn't though. Wait a minute. So this is fine. So wait, what is the actual problem with this? Maybe I'm misinterpreting what's wrong with this. Oh, no. I'm wrong. If I do this directly, now it will break in the same way. Yes. If it tries to generate a print function that takes a C string at any point, short string versions of it will fail to generate. And it's because we fuzzy match. Maybe specifically here on print. Let's just remove the fuzzy match check and see if we break everything. Yeah, we still we break all of this. Although, why do we break? What actually happened here? We just no longer generate print functions if we do that. Because oh wait, fuzzy match is what exactly is fuzzy match doing? If the types match exactly, or they're both Boolean types, or they're both string types, or they're both number types. So why does that cause this to just stop working entirely? Because we're only using it in these few places. This is in ref param matches function decl param. So if it's not, if the template argument is not an any, and it's also, we don't match, it's an any of, and we don't match any of the any ofs, and it's also the case that we don't fuzzy match. So I guess I'm confused. For each function call, we want to loop through all the function templates in the whole code base. And we're comparing the function call arg to the template arg. So if it's, we say we don't match if at any point we hit one that's not an any, and if it's an any of and we don't match the any of, and we also don't fuzzy match. Well, in this case, why are we even caring about fuzzy matching with this? There shouldn't be anything to fuzzy match against here. It's an any, right? We should be good here at this point. That's what I'm confused about. We should match that function template no matter what. Without this, why don't we match that function template? Because now we're just no longer generating these prints. Like at all. Yeah, we just don't generate them at all. That doesn't make any sense to me. If we recompile with that, now we do. We generate them. So let's figure out exactly why that's happening. Because I would think if it's not an any, and it's not an any of, or it is an any of and we don't match one of its types, then go ahead and fail. Another way we fail is if we don't fuzzy match. Let's just try this. Ignore strings equals true. String match. True. Or this. What does that do? So that does get us farther, but I guess, yeah, what are we generating now? A const char star version. Do we generate a short string version? We still don't. Right, because we're not calling that. Yeah, we still don't in that case either. I'm so confused. Oh, wait a minute. False. I totally messed that up, so... in this case, we do want to ignore strings. Yeah, something is keeping us from generating that, and I really, really would like to know why. Let's undo this. So where else are we calling fuzzy match? We're calling it there. We're calling it function name with return type exists. That's fine. That's just the return type. This ref param matches function decal param. When is this being used? Function call matches decal. Oh. Is that... I did not think I would get hung up here tonight. It's a little frustrating. I'm not sure. So what happens in like a case where we have multiple ints? Like... right? That works just fine. And we generated what? What did we generate there? U32. Oh, wait a minute. Okay, that broke as well. That didn't generate a S64 version of this. It will if this comes first, though, I think. Yes. And is that all that it generated? Yes, it did not generate... Okay. When I fuzzy match, that only matters... I don't want to fuzzy match when I'm generating these things. I just don't want to. I want explicit versions for each one. So why, if removing this... Yeah, then we just don't generate any print functions at all. Which means all right. Let's let's step through this, because at this point I am having no luck just gleaming this from the code here. So let's open VS Code. Let's do a stepperoonie. We are in metaprogram. I don't think we'll get to macros tonight. This has been a rabbit hole I wasn't expecting, but that's okay. We can remove that. Okay. Let's stop here. Okay. The function call is called function call, and it is on line 71. Which one is this? That's this first one. Okay. It should see that the call arg type is a const char star. Oh, that's the first one. Don't care about the first one. What? Excuse you? Arg index. Oh, those are. These are the required parameters, people. This, by definition, is not a required parameter. Because it's an any, ellipses. These are not required. This is not even the place to be adding this. So... get param type. Did we do some shenanigans here? Get type string from decal var. Get type string from decal var. I mean, we grab its type. All right, let's just step through. Now that I see where we're at here. Hello. Thank you. Oops. Okay. Generated function is void print. Skip the required ones. We're good there. Function is ellipsed, should be true. The extra parameters are 1. The param type is an S64. Great, generate it. Cool. Print it. Success. Let's go again. This next one is on line 83. What? Wait, all the way down here. What? Why did we just skip all 3 of these? That might be our problem right there. Why did we just skip all those? Why are we skipping? Hello? 71, 83, 82. Wait. Wow, I'm confused. I'm so confused. Oh. Oh. No? We do break out. Okay, you know what? Let's, instead of this, let's put this up here. First thing. And say that the node info, node children 0 info expr decal ref decal name is print. Let's break there. That seems like a much better place to break. Here. Okay, now function node 71, 72. Okay, that's what I wanted. So now we're on 72. I'm a little confused still why this one we didn't. We should have broken out of this. Before we move on, I'm gonna verify that because that scares me a little bit. That I don't understand why that's working the way it is. Info decal function name. Hold off on this one for now. Let's stop here again. Okay, so the function call is 71, and now we're looping over all of the templates. So we should find this one and add the function. To the program. Our generated function is void print 2 parameters. That's all good. 71 and 67. We break out of the for each. Boom. We break out of this. Which should take us back to here, which it does. 72. Okay, we just skipped over that entirely. What did we just do? I missed that. I went too fast. That was definitely the problem, though. It's not inside a template. It's not a snippet. It is a decal ref. Oh. Does it not? No, it doesn't have one. It does. What? What? How do you have a node? Print. How does this one have a node? At what point did you get a node? We're on the one that's on line 71. And it does not have one, right? Of course it doesn't. We wouldn't be here if it did. Okay. Add decal to program. Okay. So now this thing should have... No, it shouldn't. Of course it shouldn't. We haven't hooked it up yet. This doesn't do any hooking up. At all. This one is on line 72. It's got a decal ref string. This is print, right? Print. But this one has a match. How does this have a match? On line 13. In what file? Primary chunk. How is that possible? Oh, did I just hit a really gen to remove all of the... I think they get removed every time though. Okay, they're definitely not there. Oh, wait a minute. They don't get... They get removed by my script. Not just by running it. Let's remove these again. And now let's run Visual Studio. First time through. It should not have a match. Oh, this will be really stupid if this was the case. It doesn't have a match. But the second one... The second one... No, it's still matching. How is that possible? Literally, how is that possible? This source file doesn't even exist at this time. What is happening? Am I missing some print declaration somewhere? Let's remove this again. And grep for print in here. There's that. No, there's not. I don't have a print besides this one generated print function. Wow, I am so confused. How is this getting a decal ref? Like, how? There's no way. Because we're copying the body. We're not copying the... No, because we don't even make it here. We don't even make it here. Alright, hold on. Let's turn this off, turn this one back on. Actually, here. Oh my god, Visual Studio, stop being awful. Oh. Maybe I stopped being awful. Okay. Boom. Okay, first print is on line 31. Which one is this? This is in main on 31. What? Children. This is not print. Oh, because this is function call. Dude. Okay. We're on line 71. Its decal ref has no node. Great. Next one. It does. Why? Next one. Also does. Next one. Also does. Next one. This one does not. We have to figure out why those are getting connected. In what world do you get connected? I ask. Connect decal ref. Let's go there. Connect decal refs. If it's a function call, do all of our parameters, don't need this. Do all our parameters first. Actually, yes, let's put this back and do it for print. I'm so confused. Let's break here. Okay. AST is a function call on line 71. It should not find this at the end. Declref. Null, right? For each child. That's fine. Do all the parameters. That's fine. It still doesn't have one. Connect. Find and connect. It didn't find it. Next one, 72. It doesn't have one. Let me note, it does not have one. Connect the declarers to the children, doesn't matter. Here. Connect declarefs. Nothing. Nothing. Where does it pick that up? How does it pick that up? How is that possible? It's picking up a node at some point, mysteriously. And I have no idea where. Decal node equals. It can only do it here. Update function call if snippet. That should not be happening. No prints there. If macro, that won't be happening. Connect function calls. Oh. We do them all. When we add the first one, we do them all. I should only do that if it matches. So function call matches decal. Where all do we use that? Function call matches decal. We do that here in search AST. That we do want a fuzzy match, I think. You know, really, it's just here. I think just here. If function call matches decal, we'll say true. Explicit equals false. Do we do a fuzzy match in here? We have to. Ref param matches function decal param. We do there, don't we? Yes, we do. It's this one right here. So we're going to say if this is also going to have an explicit. Explicit. if explicit, else this. So if it's explicit, we return ref param type equals function decal type. And well, let's just see where we break. 1072 in snippet param. Wait. Oh, damn it. No, I just closed out of something I didn't want to close out of. What did I close? I wanted to close out of the search. Okay. Function call matches decal. Right. I have to update this. B32 explicit equals false. This doesn't go here. Codegen 700. So right here, we specifically say we don't want it explicit. Okay, we still compile, but if we look at the chunk, we generate a S64 version. Still, that's all we do. Oh, am I updating? No, this should be explicit. And then in util, generated here, we want to be explicit. We still compile, that's a good sign. We're still not generating multiple ones though. Why? Because now, if the function call matches explicitly, I'm saying explicitly, here I'm saying do it explicitly, ref param matches. We're saying, do we do it explicitly? Comparable type string. So here's one case that should not. Where is comparable type string? That doesn't matter. So if we're explicit, we need to explicitly check that the two are the same. Otherwise, we can fuzzy match. So why now? Let's go back here. So the first one, let's see if we're still even connecting up. It doesn't have one. The second one, this is the wrong thing. The first one, decal node is null. 72. It's still null. That's a good sign. So why aren't we generating this one? Wait, what? Never mind. Am I lying? Node, info, decal ref. It's null. It's still null. We're not inside a function template. We aren't part of a snippet. We have a decal ref. And decal ref is this thing. Oh, it does still have it. Wait, what am I? Oh, this is our children. God, info, decal ref. It does have it. Why does it still have it? Excuse you. Children, 0. Info, decal ref. Doesn't have it. Does have it. So, we're not out of the woods yet. Why is that happening? We want to explicitly generated decal. Where is that function? Generated decal. Connect function calls to generated decal. Let's do that. And that is in. Where are we? Util. Generated decal. Let's go here. Function call. Is this print? Nope. 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 Okay, you know what? Let's not break here. Let's break on where we actually generate the first print. Which is this first one. Here. Okay. We're going to step through until we generate it. Yep. Keep going. Yep. Yep. Right here. Add it to the program. Here we go. We connect function calls to this generated decal. We go in here. The generated function is print. We go over all function calls in the program if it matches the decal. So let's break here. This one is on line 7. It shouldn't. This one's 8, 9, 10, 11, 13, 14. Where are we right now? Are we in main? No, where are we? Oh geez, where are we? We're in the platform layer still. So let's just go until we hit 72. We know that's our first print. How about we do this? Node line number is 72. Okay, so we already did the first. Nope. I just realized this needs to be 71 because we want the first one that gets generated. So this one should be there. Print on line. Wait, what? Oh, right. This function call is copy string, which is not right. Oh, wrong thing. Copy string. Here we go. Print on line 71. Okay, we just generated this call. This first one. It takes a U32. Or no, it takes an S64. We generate it. And now we should be hooking up all these. But we shouldn't because they don't match, but we are for some reason. So let's see. Function call matches. Let's go in here. So, they match for each child. The call param is a string. The other one is a param. Ref param matches decal param. The function decal type is a short string. And the ref param is a literal string. These should match. Oh, wait a minute. Oh. That's why. If I break fuzzy matching, that breaks on the first parameter, the format string. That's why it wasn't generating print functions at all. I only want to break fuzzy matching on innies, I think. Which means, let's just keep going, but, so the first one matches. The next one is T3, which is a variable whose type is a S64. And the call parameter, the function decal parameter type is S64. Wait. Yes, this is the first one. Oh, hold on. Am I doing redundant work here? If node does not equal generated function decal, right? We already did ourselves, so I need to back out of this. That was a mistake. Okay. Print. Boom. Okay. Oh, wait, this needs to be... This here needs to be... Okay, I'm confusing myself. This is one of those nights where my brain ain't braining. We do want to connect this, don't we? Yeah, because we don't connect it here. Jesus. Here, add a breakpoint. Boom. if the node's line number is 72. That's when I want to break. Here. So, function call matches decal. I did not mean to do that. I want to step into this, please. Same number of parameters. The call param is a literal string. The param type, that's fine, this is the first one. Second one, call param, is a decal ref to T1, which is a U32. The decal param is a S64. These should not match. You feel me? Alright, the function decal type is an S64. And the ref param type okay. So, call param. Wait. Function decal param is an S64. Ref param type is a U32. These should not match in this case. And are we saying we're not explicit? We should be. We're set to true. Explicit is 1. Oh, we're not passing it through. What a blunder of all blunders. We're not passing this through to... Bro. 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 Pass this through. What are you doing? Oh my god. Okay. Alright, we lost one of our prints, which is good, because we don't print out floats right now. Which means the floating one is properly failing now. Because before it was piggybacking off of the other one. S64, U32, U8, F32. We print all of them now. And it shouldn't matter the order we do it in either. Yes. U32, U8, S64. Okay. So, now, do these two work? No. What if, does just that one work? No. Does just this one work? No. Okay. Oh, alright. So, why not? A little bit closer. Now we're on 64 and 65. So let's go back here and say 64. The generated function takes two parameters, a short string probably, format string, and ellipsis arc0, which is a char star, a const char star. which should be that one. That's 65 though. Oh, we're on the wrong thing? We are on the wrong thing. Two literal strings. Wait. Oh, this is a literal string. That is not a short string. These are both literal strings. Duh. This is a C string. Right. So. Let's see. Okay. The first one is a literal string. Is this just the format? It is %/n. So skip it. Don't care about this one. Okay. The call param is a literal string whose value is the name of the file. And the function decl param because what are we checking? We're checking the print function that got generated with a const char star. Right? Const char star, this is a literal string. Those should match. So let's go in here. The function decl type is char star. That should be true. Okay. So we found a match for that one. Great. Which is the one we just generated. What are we failing on then? Oh, we're failing on the short string one. The character star one is fine. This one we're failing on, trying to print out a short string. Right? Test function 90. Oh, wait. This should be a better error. Oh no, this is the compiler erroring. So 90. I feel like the stream is all over the place tonight, but that's okay. 90. Yeah, this is trying to generate, or trying to call one that has a short string. So, let's break here on line 90 instead. Print. This should be line 90. Print 90. So, this node should be in primary chunk. It's not. It's not. What are we doing here? primary chunk, line 90. So now let's go back here. Okay. Node should be on line 90, and it should be in Why are we back at dynamic string? What is happening? Print line 90 in primary chunk. Declref is here. But it already has one. Line 90. What am I passing it? This. Declref. Index. Nope, that's not what I want. I want this one. Member ref. Declref. Dynamic, which is a struct member whose type is short string. That's all I wanted. And what is it connected to? A print function that takes a keystar. Okay, so we matched that wrong one again. We matched that wrong one again. So this first one here, 64. Go back here. And then we'll go here. So this node should be in dynamic string. I'm confused. Why are we never hitting this? Can I be like... Wait a minute. That might be happening in a subsequent pass. Is that possible? We generate this print function. We generate this print function. We eventually call this, which... I don't actually know. Let's try this. Let's I'm going to do this real quick. So I think I'm wondering what's happening is if this secondary print that's being generated on the short strings, since it's in the primary chunk, that it's happening on a second pass. That's what I'm wondering. we will have to see. So let's not break here either. Let's go to codegen and let's go to run metaprograms. First we run the main one, and then here we run it a second time. So let's get there first. And now let's break on this one. On line 90. So this is a function call on line 90 called print. It's parent, 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 parent is the primary chunk, line 90. This is where we want to be, right? So, does it have a pointed decal ref? It does. Oh, of course it does. Of course it does. Because when we run this second time, we generate those, we run a post pass on it, which hooks them up. What if I just say all of them have to be explicit? What happens? Ref param matches. Function call matches decal. What if they all have to be explicit? It all works. Maybe we just let everything be super explicit. Why do we not? So now, const char star, and the second time through, u32, short string. If we just make them all be explicit, everything just kind of works. Maybe that's what we do. I'm going to put a big ol' to do there, but I need to make sure I really understand that before fully committing to it. So function call matches decal, explicit equals true. To do, oop. Really understand this change and remove this extra variable altogether. This making all type matches be explicit seems to fix a lot of weird edge cases. Yes, so making all type matches be explicit to fix a lot of weird edge cases. However, I haven't really thought through this change and just kind of did it. So for now, I'm just keeping the variable, the parameter in here and forcing it to true until I can verify things are hunky dory. Okay. That was a detour and a half. So, but that's all working now, so you can see we can get the file name now. Just by doing this. Pound file name. In fact, because it's an expression, I should be able to say this. And do this. Right? Still works. Next thing I want to do is be able to print the... In fact, let's just do all of them right here. Print the file name, function, line number, counter. Function, line number, and counter. Okay. It doesn't know what a few of these are now, so parse call params. Parse call params. Parse expression leaf. That should honestly be a better error message. Param call parse call params. Assertion failed. Param node. Parse call params. This here. Let's say if not param node, report error and parse error. Parser on the next in AST expression function call. Error message will be parse error. So unable to determine, or failed to parse expression in parameter, in function call parameter. That's a better error message for sure. 6518, so if I go to that, 6518, so we can see it points to the right thing. Great. Now let's do the rest of these. So parse expression leaf. File name was easy. Else if it's function. Do I have a get containing function? This should go in the parser. get containing function. If the directive is function, then function equals get containing function of the of what though? Should plug my phone in. I think what we have to do here is error context. That can technically be a post-pass thing. In fact, should all of these be post-pass things? Maybe? Maybe these are all post-pass things. That might make the most sense. Yeah, let's do all this in a post pass. If we go to codegen, post pass, update macro calls, snippet calls, replace snippet call. So at the very end, the very last thing we will do is update custom preprocs, I guess. Hey Chris, hope it's going well tonight. This was supposed to be a short stream, but I have super rabbit holed on something, but I solved it, so now I'm just gonna finish up this last little bit and probably call it, but it happens. How's your night going? Let's update custom preprocs. It will take the parser and the AST. So for each preproc, okay, dude, I don't know if I talked to you about this. Literally in the last month, I randomly, so both of my brothers, especially my older one, are into Magic. Like literally last month, I just randomly decided that sounds kind of fun, and I've gotten into Magic in the last month. So we meet like every Sunday for the most part and play, so you and I definitely have to play. I'm having a lot of fun with it, so. Okay, if it's a pre-proc, let's just skip it. Actually, we'll keep this here, because we will verify that we found the right ones. In fact, let's do that now. directive ID is 0, directive ID is less than array count. Custom simple directives, and we'll say if directive does not equal wait, no, we'll say matches is false if directive so yeah, we'll definitely play. So what are the rabbit holes I'm working on now? So what I'm doing right now is so in this like pseudo language, my DB files, I am basically replacing I'm replacing macros entirely because macros don't play well with the metaprogramming stuff because they are like purely a textual replacement. They don't get parsed or anything by the compiler. They just are plugged in, copy-paste style. And that just doesn't work very well with my metaprogramming stuff because I want to parse the whole file and know what everything is doing. So I've come up with these things called snippets, which are basically macros, but they are parsed properly as like a syntax tree and plugged into the tree at metaprogramming time. So I at this point I've already replaced all my macros with those, but I am missing some stuff that macros give you, like stringification of variables you pass in. They don't support that yet. That was one of the things I was going to do tonight, but what I've rabbit holed on was the other thing that I don't want to have to rely on are these macros that are given to you by C. Like that'll give you the line number, that'll get you the file name. I think that will give you the function name wherever you use it. I don't want to rely on those things, so I'm making my own that you can call. So here, like you can just say pound file name, function, line number, counter. But anyway, in the process of getting this to work, it revealed a problem in my type resolution in the parser and the codegen that took me most of this stream to figure out. But now that I have, I can get back to actually implementing these 4 keywords. So that's a brief overview of what my night has been so far. And the thing I'm doing now is, before I was parsing these at the call site here, and then I realized really I can just look for all these in a post pass later and replace them later, which makes more sense. So now I'm just doing that. Hopefully that makes sense. And I guess it's only been 2 hours. It feels a lot longer than it has been, but okay. This is gonna be, so if the directive equals any of these, we'll say matches is true, and we can break out of this thing. So if matches, we just skip, or no, if it doesn't match, we can error. Yeah, no worries. It turned out to be a thing where I was doing a bunch of fuzzy matching. So just as a quick overview, this file name is a C string, but I have my own struct which is called short string, which is just it's just a character array with a length included, so it's like a counted string. You always have the length. And in the parser, I was fuzzy matching those things. It it would say, oh, this function takes a C string. Well, I'll match a short string to it, and vice versa. And it was making it so if both of those things existed at once, one of them wouldn't be generated because it thinks that it already was, and it was causing all sorts of problems. Similarly, if I had like this, you know, all of these are numbers, so it was fuzzy matching all of them, and it wasn't generating all of the functions that it should be. Basically, what was the underlying issue there? Okay, so if it doesn't match, this will be a parse error. Parser next context, and we're gonna say unrecognized preproc token in expression. Do I not have context? Oh, error context is what this is called. Failed to parse expression in function call parameter. Great. Failed to parse expression in function call parameter. Because I still need to return this thing. Oh, I still need to make one. Doi. Crap, I should not have removed that. Let's copy this and get this back. Here we go. Boom. And let's keep this. So if we match, let's create a preproc node. AST, what do we call those? Oop. Oh boy. Preproc. Oh. Custom simple directives, that's in the lexer. Right. I do have to still check this though. We'll say you know what? Let's make this just custom. And we'll just call this custom. Or marker. I don't know what you would call these. I'll just call them markers for now. So we're going to create one of these markers. Preproc marker. Assert that we got one. Okay, so this is no longer true. Preproc info. We'll make a new one of these. This will be a marker, and all it will have is the type. So, I have to make a new one of these. Marker. Okay. So, info preproc marker, and this is the preproc node. The marker's type is how would we do this? We'll say -1 is the match ID. If that's true, match ID will equal directive ID. And we'll break if match ID is less than 0. And then here we can say the type will be equal to, is this just type? Token. Okay. Result is the preproc node. We skip over it. Directive ID. Right, this is the match ID. Comparison of integers S32 and long 1626. What? True. Okay. Parsing function call expected expression got semicolon on line 64. What did I do? Okay, we broke this somehow. How did we break this? Because we're skipping over twice now. That's no good. Okay, unable to resolve type. Right, yes, okay. So we're done parsing. Now we just need to do our post pass and update these things. So, for each node type, for each preproc marker, well, let's just do this. For each marker in the program, let's get the type, token type. It's node info preproc marker dot type, and we will switch on the type. And actually, you know what? We don't need to make this a variable. We're just going to use it in this one spot. So token, what are our tokens? Wait. Oh. They're all preprocs. Wait. Did I screw that up? Oh, they're all preprocs, that's why. I don't want the type here. I don't want the type. I want the name. That's what I want. So in here, I want the directive. So we're not doing this. We're saying node info preproc marker dot name. If name is file name, Cool. Yeah, see you, Chris. Thanks for hanging out. Yeah, I'm definitely excited to play Magic with you. That sounds fun. I'm really enjoying my time with it so far, so we'll definitely have to catch up and do that. I hope you have a good night. Function line number counter. Okay. So, if it's the file name, I just want to let's do this. Metagen parser node, new replacement node is create node on the parser, whose type is a marker. Or no, it is already a marker. Right, we don't have one yet. So if it's a file name, then replacement node will be create node on the parser, and it will be a literal string. Create node. Do I not have to pass? I'm a little confused why I don't have to pass. Is it implicit? Where is that coming from? Create node. Oh, this one is implicit. That's confusing, but whatever. Replacement node. Info. Literal value dot string is going to be allocate dstring parser arena, and we're gonna be do I have get containing file? Get source file, get source node for this node, and it's gonna be info source file dot path. Okay, easy enough. If it's a function, then this will be not get source node for, but it'll be get containing function. And actually, we can go back to here and put this back where it was. This doesn't have to be in the parser. This can be in util where it was. That's fine. Okay. Function, get containing function, info, decal function, dot name. I somehow turned off wrapping, and I don't know how I did that. Or for coders just getting confused. That's weird. Line number is a little different. So line number, we're going to be adding a literal unsigned int. Literal, what did I call it? Integer. Although wait, I have both in here. How do I distinguish the two? Oh, it's on the type. It's on the type. Right, I need to do this. Type is token literal string, This one is token literal string. This one is token literal unsigned int. And this will be unsigned integer is node line number. Great. And then counter. So for counter, what we're going to do is we need a global globally accessible accumulator. So on the parser, we'll just say U32 pre-proc counter, and we'll just say do the same thing, but the value will be global parser pre-proc counter plus plus. Yeah? And then we can remove this node. But before we do that, we will insert add child. What is it called? Is it just insert before node replacement node? Do I have like a replace? I do have replace node. Haha. Replace node. Existing replacement. This is gonna work on the first try? I guess not. 1626. This is no longer type. This is name. Get containing function. Right. This has to go higher up. Oh, I was really hoping that worked. Call to int is ambiguous. Really? So if I don't do this, do we work? That works, cool. What if I do just like that? That works. And does that also work? No. So that's a little weird, but I don't think that's the cause of this problem. So this, that does work, line 66. Does this? Oh, it's just that one. That works. Counter doesn't. Create a literal integer, unsigned int, preproc counter. Those are literally the same thing. Like, quite literally, those are the same thing. I'm confused. Is counter like... There's no way, right? Is there just one I did not... Oh, is... No. I don't think this is a thing. Yeah, like there's not... That's not a thing. So what exactly does it not like about this? But this one it's fine with. They're the same thing. These are identical. I'm so confused. Bro. Why? What are we doing here? Why is this broken? Ambiguous. Okay. What if I literally make an int and I print it out? That works too. Why, I ask you, really? That's what I wanted. But if I put counter in here directly, it doesn't understand. Counter. Why? So let's look at this. X is 0, X is 1, X is 2, X is 3. In this case, print 0. Is it because it's specifically 0? Oh, that's funny. No. I thought I already tried this and that worked fine. What is happening? That works. That works. That doesn't. And that doesn't. Why is it ambiguous? we have one that takes an S64. Oh. It can't match on the numbers. Okay. So that one we don't care about. This one we're always being explicit. Well, actually, we're not really, but I think we are, because the only people that call to that are, yeah, are already doing that. You know what? Let's, turn that off for now. And now we should break, these now. No? Oh, we will if it's a short string. No. What? Oh. We're just calling it true in both places. Okay. That's fine. Matches decal. So let's remove this. Boom. Boom. Let's remove all these. Let's go back to just fuzzy matching, but let's not match on strings. No, wait, that's where we just were. Okay, yeah, no, that's not how that works. Instead, what needs to happen is oh god. That's fine. Move this. Okay. We've got some problems for sure. So the problem is, if we ever have just a regular integer literal, The problem is that they are just they aren't they aren't explicit enough, so it thinks this is an ambiguous situation. It thinks this is ambiguous unless I disambiguate it. Yeah. If I disambiguate it for it, it's fine. Jeez. Okay. Let's just have a comment in there. Oh, jeez, I'm very tired. Comment in there explaining what's going on. This is ambiguous. This is fine. This breaks the above line number and counter variables too, because we are just sticking literal integers onto the tree. Exposing an existing problem. Codegen. Okay. Well, I really want that to work. If I just do this, it will. There you go. But I think I'll have to call it now for tonight. I'm way too tired. Some of this took way longer than it should have because of how tired I am. And that's okay. I fixed a pretty major thing in the parser that this exposed, and then I at least have these functional. These are functional, it's just exposing another problem in the parser, codegen stuff, so it will be fixed. Let's clean this up because I feel like it. Okay. Well, thanks for watching, everybody. It got late. I don't even know if anyone's still watching. But if you were watching at any point, if you're still watching, if you catch the VOD, thanks a lot, and I will catch